All right, so in this lesson, we are going to calculate and interpret. Calculate and interpret the volume of cones, and we're going to use the formula again. So, volume of a cone. The formula for volume of a cone is V equals 1/3. Let's put a different color. We'll put B, capital B, and then H. I think the yellow might be too close to the orange. So let's do BH. Where capital B, once again, is area of the base. And H is the height of the 3D object. Oh, we'll just say height of the cylinder. That'll make it easier. Height of this. Oh, cone. We're doing cones today. So if you could do yesterday's, today should be all right. Should be all right. So example 1. We have this cone. Circle goes to a point. Let's shade and draw our base first. So I'm going to do that with blue. So there's my base. The thing about cones is that they only have one base. Normally we have like two that are the same, right? But we only have one base. So, oops. Let's try. Okay, that's good enough. And our radius is 4 centimeters. Cool. Remember, this is the base. Cool. And let's write our formula. V equals capital B. Oh, 1/3. Let's do, I forget what it was. Green? I think, yeah, green. And then H. So, capital B is area of the base. I want to remind you that capital B is area of the base. So, our base is a circle. So, we're looking for like how many squares it takes to cover this circle. Oh, I guess I could be like how many squares it would take, right? So on and so forth. So, to get the area of a circle, I guess I should point to this. A circle. Well, I'm doing blue. A circle. And so to get the area of a circle, we have to do pi r squared. So pi radius, which is 4 centimeters. I guess I can put that one in blue, since I have it blue over there, squared. So we get 16, or pi, times 16 centimeters squared, which just becomes 16 pi centimeters squared. This is our exact answer. Don't forget that it's useful to get an approximate answer. So let's go ahead and do that. Oh, and let's go ahead and make pi. We will estimate, we'll make pi. That's a color I didn't use. We'll say that pi is, well, pi is approximately, I can't even write pi for some reason. Okay, let's try this again. Pi is approximately 3.14. So that's what I'm going to use when I do these calculations. 16 times 3.14 is 50.24. So the area of the base, the area of the base is approximately 50.24 square centimeters. Okay, the height is right here. So the height is Oh wait, that's not the height. I didn't label the height. I almost made that mistake. The height's right here. I forgot to write it in because usually you won't have to calculate it. You could do it using the Pythagorean theorem, a squared plus b squared equals c squared. But I'm just going to give it to you, 3 centimeters. So our height is 3 centimeters. Okay, so let's do the volume. Well, we'll just put equals 1/3 area of the base, which is 16 pi centimeters squared. And then we multiply that by our height, which is 3 centimeters. Okay, so you can do quite a few things here. What I would do is I would multiply the 1/3, the 16, and the 3, and I would leave the pi for later. Actually, no, maybe it look a little bit more like a regular pi. Okay, so let's do this. 16 times 3. 16 times 3 is 48. 16 times 3 is 48. And then to get 1/3, you would divide by 3. So we'll put 48 divided by 3. And then we'll put pi centimeters to the third, because centimeter squared times centimeters to the third. I'm actually going to do this. My equal sign's a little high for me. So you get equals 48 over 3 pi centimeters cubed. Now, one might think that this is like simplified, but like we can actually divide 48 divided by 3. 48, always check. 48 divided by 3 is 16. So 16 pi centimeters cubed. That is our exact answer. And then we get, which makes sense actually, because if we do 16 times 3 and then we divide by 3, then we just get back to 16, if that makes sense. So our volume is approximately 50.24 centimeters cubed. Remember, 16 times pi right there. Okay, statement. So the entire cone is made of, or can hold approximately 50.24 centimeter cubes. Cool. Let's go to the next page.